All right, my friends, today we are looking at lesson 3, derivatives of primary trigonometric functions. So problem 1, use the formula f prime of x is equal to limit as h goes to 0 of f of x plus h minus f of x over h to determine the derivative of f of x equals sine x. In other words, we're using the definition of the derivative to figure out what the derivative of sine x is. Once we do this once, we don't have to do it again. So this is going to be f prime of x is equal to the limit as h goes to 0. So we're looking at our f of x plus h. Since f of x is sine x, this gives us sine of x plus h minus my f of x, which is just sine x, all over h. Okay, so now that we've got our setup, let's solve this thing down. Again, we know that we can't dive in right away and replace h with 0 because can't divide by 0, so we need to do some fun limit stuff here. So first thing I'm going to do is I'm going to expand this thing out. So I'm going to use the sum identity on that sine of x plus h. And if you recall the sum identity, this means that this is going to be sine of x cosine of h plus cosine of x, sine of h, and then we still have that minus sine x. We haven't done anything with that yet. So again, that's just using the sum identity. Just one of your basic trig identities. All right, and we continue on here. What I can do now is I can actually factor a sine x out of two of those terms. So I'm going to factor sine x out of the first term and the last term. So if I pull sine x out, what that leaves me from the first term, so you see we have sine x there and we have sine x here. So if I pull the sine x out to the front, what I've got left is cosine of h minus 1. And then I still, of course, have the cos x sine h. And that's all over h. All right. Next thing I'm going to do is I'm going to split this thing up a little bit. So I'm going to pull that sine x out front. And what that leaves me with is cosine of h minus 1 all over h. And then I'm going to factor out the cosine of x out of that second term there. And that's just going to leave me with sine h over h. So just factoring those things out. This means, though, from our previous lessons, we know that cos of h minus 1 all over h goes to 0. And sine of h over h goes to 1. Again, that is in reference to our previous lessons on limits, where we determined the limits of trig functions. Go back and check those notes if you've forgotten that. Make sure you know those identities. They are very useful. This leaves us with the idea that f prime of x must be equal to sine of x times 0 plus 1, I don't know why I wrote it like that, plus cosine of x times 1, which, when we calculate it out, is just cosine x. So yeah, that's right. The derivative of sine x is just cosine x. So that gives us some really nice, useful information. In general, the derivative of sine x is equal to cos x. And we could use this exact same procedure to find the derivative of cos x. I'm not going to go all the way through it. You are welcome to go through and do it yourself if you want to check this. But it's the same procedure. We should be getting cos x is equal to negative sine x. Those are two really important factoids. They are on your formula sheet, but they are ones you're probably just going to want to have memorized because they're simple and it's better than having to check your giant formula sheet every 5 seconds. So we're going to use those to solve a bunch of problems. Otherwise, all the rest of the differentiation, same as we've always done. Only thing we've changed now is we've added some trig. So let's look at problem 2 here. Differentiate the following functions. Y is equal to sine of 4x cubed. So I'm going to bust out my chain rule here. Now, just like when we did derivatives and chain rule the first time, we start going slow, and then eventually we're gonna dump a lot of this intermediate steps. But I'm going to start doing it the proper way. So I'm going to use that u value here. I'm going to let u be equal to 4x cubed. And we're having y can then be written as sine of u. Again, this is just a nice substitution to make it a little easier for us to solve. So just recall that this means dy dx is going to be equal to du dx times dy du. So if I can solve for du dx and dy du, I'm golden. So du dx is equal to, well, this is just the derivative of 4x cubed. So that's going to be 12x squared. Dx dx. Again, that's just chain rule. I know we usually don't bother, but just reminding you that technically it's there. And obviously dx dx just becomes 1, so we can ignore that one. And then we have dy dx is equal to cosine of u, because the derivative of sine u, as we just discovered, is cosine u. And again, du du. Sorry, that was the derivative dy du. Sorry, I wrote dx. So the derivative dy du is going to be cosine u, du du. Again, du du just goes to 1, so we can ignore it. So this means that dy dx must be equal to 12x squared times the cosine, and this is where we substitute u back in with our original expression, 4x cubed. And that's that. All right, so in B, I'm not going to do that long form du dx, dy du chain rule version, because I know we don't usually bother with it once we get the hang of chain rule. That was just to remind you how chain rule works in this new setting. Now I'm going to jump back into the way we usually do chain rule, which is more by inspection. So I've got y is equal to sine cubed of x, which, if you recall, is the same thing as sine x all cubed. So I've got that piece, so that means that dy dx is going to be, I'm going to bring down the 3 times sine x squared, and then of course it's chain rule, so I have to multiply by the derivative of the interior, right? I can't just do power rule and be done, I have to do the chain rule. So this is going to be times cos x, and then the interior function of cosine x is just x, which of course is just dx dx, which we usually ignore. So what that leaves me with is that dy dx is equal to 3 sine squared x, I'm switching back to our usual way of writing that, times cosine x. Or 3 cos x sine squared x, it doesn't matter. Okie dokie. So just be careful, make sure you're using chain rule all the way through. Don't just use power rule and call it a day. We need to make sure we're following through with chain rule. Ooks dokes. One more of these, and then we'll get into something a little bit trickier. So we've got y is equal to sine cubed of 4x cubed. Again, we can rewrite that as sine of 4x cubed, all cubed. So this is, again, we're going to bust out our chain rule. So let's do some chain rule. Chain rule! Not as good as power rule, I know. So dy dx is going to be equal to, so again, we're going to pull down that exponent, 3 goes out front, then we have our interior function, sine of 4x cubed, all squared. Okay, right? So that's just the basic power rule. Power rule. See, that one is better. There's my interior function, 4x cubed, right? That's my u value. So I have to take the derivative of that. So the derivative of 4x cubed is So I have to look at my interior function. Right there, sine of 4x cubed is my interior function. So I have to take the derivative of that, which is going to be, well, we know the derivative of sine is cos. So that's going to be cos of 4x cubed is my interior function there. But then the interior function of that is 4x cubed. So I have to take the derivative of that as well. Chain rule, right? So that becomes 12x squared. And then my interior function of 12x squared is x. So I take the derivative of that, and I get dx dx, which is when I know I can stop. If you're ever really not sure when to stop the chain rule, basically once you get to dx dx, you're done. So now that I have all that, I can lay out my final answer. We have ourselves, we can group some coefficients here. 3 and 12 make 36. And I have that x squared there as well, so 36x squared, cosine of 4x cubed, sine squared 4x cubed. And there you go. So don't forget, chain rule all the way through. Okay, we got ourselves 4 problems here. So we're going to start with this one. This one's nice and easy. I'm going to do these ones a little bit faster. dy dx of sine 3x. Well, we're just going to be taking the derivative of the outside function, which is going to be cosine 3x, but we're also going to multiply by the derivative of the interior function. So this is going to be 3 cos 3x. Then we've got b here. Y is equal to cos of 3x plus 2. So again, we're going to take the derivative of our outside function. Derivative of cos is sine. So that's going to be sine of 3x plus 2, but the derivative of the interior function, negative sine. Negative sine of 3x plus 2, but the derivative of the inside function of 3x plus 2 is 3. So this is going to be negative 3 sine of 3x squared plus 2. Sorry, 3x plus 2. I can't talk today, or, most days. So I'm skipping some steps here, but the hope is that you're doing these ones on your own first, that you're not just following along with me. All right, we've got y is equal to sine of x cubed, so same idea as before. We've got y is equal to, again, we've got cosine is our derivative of our exterior function, and our interior function is 3x squared, so that goes out front. So we have y is equal to 3x squared cosine of x cubed. And finally, this last one. This one's a little bit trickier, a little bit more going on here, so I'm going to rewrite this one as cosine of x squared minus 1, but I'm going to put that all to the power of 5. This just makes it a little easier to see our chain rule. So this means that dy dx, well, first I'm going to do my exterior function. That's going to be 5 times cosine of x squared minus 1. And then I have to multiply by my exterior function again, which is of cosine. The derivative of cosine is negative sine of x squared minus 1. And then I have to take the derivative of that interior function, which is going to be 2x. And again, I could take the derivative again and get that dx dx, but I'm not going to do that anymore. That we all know derivative of 2x is just going to be, oh, sorry, I can't math today. The derivative of x is dx dx, so we can kind of skip that. Sorry if I'm confusing you with my lack of ability to talk, but honestly, you guys should kind of be used to it by now. So what we've got here is we're going to multiply 5, 2, and negative 1 to get negative 10x. Then we just pull the rest of our stuff together. And you might notice a mistake that I definitely made. When I took the initial derivative of cos x squared minus 1 all to the power of 5, I forgot when I pulled down my 5 that an exponent of 4 remains. See, there you go. So that's going to be 10x times cosine to the power of 4 of x squared minus 1 times sine of x squared minus 1. There we go. All right, so that's the basics of how to find these derivatives. Let's try something just a little bit trickier. So let's try something a little more complicated. Let's take a look at this next one. Y is equal to x cubed times sine of x. So when we look at this, the first thing we should think is this is totally a product rule problem. We've got ourselves two functions of x being multiplied together. That's product rule. So we've got y is equal to, so let's break this down. This is going to be x cubed and sine of x are our two functions. I'm going to call this guy my f and this guy my g. Okay? So when I go through this, we know y. Well, if we remember our product rule, what we're going to be looking for is f prime times g plus f g prime. So first we start with f prime, which is 3x squared, and we multiply that by g, which is sine x, plus our f, which is just x cubed, times g prime, which is cosine of x. So what we get when we simplify this is just 3x squared sine x plus x cubed. Whew. Silly, Sam. Tricks are for kids. dy dx. That's what I was looking for. X cubed cosine of x. If you thought for a second that because I was doing this at home without children around me and that I have the ability to edit using editing software, that anything would change from our usual lessons, you were sorely mistaken. All right, so that's how we use the product rule on trig. It's no different than product rule on not trig. Let's try then this one. Well, notice that we've got ourselves an implicit function of y. Got ourselves an implicit function here, so we're going to be doing implicit derivatives here. So what we've got to do is take the derivatives of both sides. So I'm going to take d dx of sine x plus sine y, and that's going to be equal to d dx of 1. So when I take my derivatives, this one's not too bad. The derivative of sine x is just cosine of x, and it's a derivative of x, so the interior there is dx dx, which we can cancel, right? But the derivative of sine y, well, that's cosine y, but the interior function there is dy dx, which we can't cancel, right? We got to keep that. And the derivative d dx of 1 is obviously just 0. So what we're left with then, when we simplify this, is we've got ourselves cosine of x is equal to negative, I regret my life choices. I'm going to switch it the other way around. Let's do cosine of y, dy dx, is equal to negative cosine of x. Then we divide both sides, we get dy dx is equal to negative cosine of x all over cosine of y. And there we go, that's our implicit derivative. Okay, so that's all of our basic derivative stuff. We've covered product rule and chain rule and power rule and implicit functions. You might notice a particular rule that we've skipped. Don't worry, we're getting to that. Let's look at an actual problem. So show that the equation of the line tangent to the curve y is equal to sine x over cosine of 2x when x is equal to pi over 6 is 3 root 3x minus y plus 1 minus 3 pi, root 3 pi over 2 equals 0. Whew. That looks really gross, and I totally acknowledge that that looks really gross. But it's actually not as bad as you think. If you really look at this guy, what it really is we've got ourselves ax, right, plus by plus c is equal to 0. So it's just that we've got the different parts. Here's my a value. Here's my b value. And here's my c value. So it's just the general form of an equation of a line. Nothing we haven't done before. So we're just basically finding the general equation of the tangent to the line when x is pi over 6. So recall the tangent to a curve, the slope of the tangent to a curve is always the derivative. So slope tangent is going to be the derivative, dy dx. So we need to take ourselves the derivative. Now, take note that we're clearly going to have to use quotient rule. So our first step is going to be slope of tangent. And we're definitely going to need to use quotient rule here. Okay, let's be real. We could change that cos 2x to cos to the negative 1 of 2x, and then use chain rule and product rule, but I think that actually sounds harder. So let's just stick to quotient rule. So we're going to use quotient rule here. And again, we're just going to be using our standard f prime g minus g prime f all over g squared. So what I've got here is the derivative of f. Well, let's do these on the side, just to make sure we don't get lost. So just over here, I'm just going to do a really quick, f is sine x, g is cosine of 2x, which means f prime is going to be cosine of x, and g prime is going to be negative 2 sine of 2x. Okay, that's just using our basic derivative functions we already know, so I'm just going to put that on the side just so we have it. So what that gives me is that we have cosine of x times cosine of 2x, that's our f prime and our g, f prime and g, minus negative 2 sine of 2x times sine of x. And that's our g prime and our f. Then we divide that whole thing by g squared, which is cosine of 2x all to the power of 2. So that's our g squared. So that's just regular quotient rule. So if we continue on down the line then, that means that our slope of our tangent specifically, slope of this tangent specifically when x is equal to pi over 6, that means it's going to help us simplify this a lot, is going to be equal to cosine of pi over 6 times cosine of 2 times pi over 6 minus, well, I'm going to do plus, minus times minus is plus, so I'm just going to group those right now to get that out of the way. 2 times sine of 2 times pi over 6. And finally, sine pi over 6 all over cosine of 2 times pi over 6 all squared. Whew. Okay. Now it seems like a lot, but don't worry, it simplifies pretty quickly. So I'm going to do one extra quick step. Some of you might have already seen this. Probably a lot of you have seen this already, but that's cos of pi over 6. This becomes cos of just pi over 3, right? 2 times pi over 6 is pi over 3. So we can simplify this, make it a little bit easier. So again, this is where knowing your unit circle is really handy, because if you know your unit circle decently, even if you just know the first quadrant, you can do most of this work in your head. If not, make sure before you get started on something like this that you have a copy of the unit circle, or you make a copy of the unit circle for you to reference. But cos of pi over 6 is root 3 over 2. Cos of pi over 3 is 1/2. Sine of pi over 3 is root 3 over 2, so this is going to be 2 times root 3 over 2, which we know will simplify really nice, times sine of pi over 6 is 1/2, all over cos of pi over 3 is 1/2 to the power of 2, which we simplify it even further, will give us root 3 over 4. We can see that the 2's here cancel out, so we can just go with plus root 3 over 2 all over 1 over 4. And if we simplify that down a little bit more, just basic algebra, common denominator for root 3 over 4 and root 3 over 2 is 4. So if I group those together, what I end up getting, and I flip that 1/4 back to the top there, I get 4 times 3 root 3 over 4. So that's just your algebraic simplification. Make sure you can work with fractions like this. And that, ooh, that was weird. And that finishes us off with 3 root 3 as our slope. So that's our slope, but hey, are we done? We're not done. We're not done at all. So if we jump ahead here to the other next page, just to get us some more space, the next thing we need to do is we need to establish the point of tangency. So we already have the slope, and we have our x value. So when x is equal to pi over 6, we go back to our original formula, if you've forgotten that by now, because it was a while ago. This is a big problem. But if you recall, our original formula was that y is equal to sine x over cos of 2x. So when I bust this puppy up, I don't know why I'm busting this poor puppy up. That's a horrible turn of phrase. I should edit that in post. I probably won't. Y, we know, is equal to sine of x all over cosine of 2x, which means that y is equal to sine of pi over 6 all over cosine of 2 times pi over 6. Which means that this is y is equal to sine of pi over 6 is just, well, I'll do one more step. I think you can probably see this one by now. It's cos of pi over 3. But that gives me 1/2 all over 1/2. Sine of pi over 6 is 1/2. Cos of pi over 3 is 1/2. And obviously that is 1. So our y value is 1. So that means our point of tangency is going to be pi over 6, comma 1. So that's our point of tangency. So getting our line, which is the final step, is pretty easy. Everyone kind of has a preference here. Some of you like to use y equals mx plus b and put in all the values. Some people like to use point slope form. I just like using the slope formula, right? We know that y is equal to, sorry, not y, slope. Slope is equal to y minus y1 all over x minus x1. So I can just plug those values in. I have my slope, it's 3 root 3. I have my y value is my unknown here, but I do know that my y value, my y1 is 1, and I've got x minus my x value of pi over 6. Then I'm just going to multiply x and minus pi over 6 to the other side. This is 3 root 3 times x minus pi over 6 is equal to y minus 1. Now that I've got that, I can just simplify this whole thing out. So I've got 3 root 3 x minus pi over 2, because the 3 and the 6 will cancel, so this is going to be pi over 2 root 3. Let's just multiplying that out, distributive property, is y minus 1. Then I move everything over so that I can get my 0 value, and I get that 3 root 3 x minus pi over 2, I'm going to do this in order, minus y, plus 1 minus root 3 over pi, root 3 pi over 2, sorry, is equal to 0. And hey, that was what we were originally given. That's our line. All done. Proven. There's our little square of proof. We did it! Hooray! All right, and that's it. We are done. So there's homework questions from your textbook assigned there at the bottom. Remember, if you have any questions, to get in touch with me so that I can go over any problems that you might have. Otherwise, see you in the next lesson. Peace.